All right, so here we go. We are going to, there it is right there. Okay, it says page 57 at the top. We skipped some, so we haven't done 57 pages yet, but that's where we're starting, okay? So here we go. How many ways can you arrange 5 books on a shelf? Now, does anybody just want to take a wild guess before we start?
25.
That's a good guess. It's not the right answer, but it's a good guess.
10. 15.
Okay, we got great guesses. Let's look at how we do this. Let's pretend that this is your bookshelf. And there are 5 slots on your bookshelf because you are going to put 5 books on that shelf. Okay?
Is it 125?
No, but you're getting closer.
320.
Now, here's what I want you to do. Here's the stack of books right here in front of me. There's 5 of them. All right? I'm just going to close my eyes, reach in, grab one, and put it here in this spot. How many choices do I have? 5. So I reach in and grab one book. That 5 represents 5 choices for that spot. Okay? So I reach in, grab one, put it there. Now, I'm going to reach in, grab another one to put it here. How many choices? Now there's only 4. Does everybody see that? Because I already put one there. So now there's only 4 left for this spot. And then there will be 3, and then 2, and then 1. These numbers get multiplied. If you remember nothing else I say today, I want you to remember this. If your problem says or implies that there are 5 choices here and 4 here and 3 here, when you are doing this and this and this, you multiply. That's always a multiply situation.
Are these the next chapter's notes?
Yes.
I don't have them.
Yes, you do. I gave them to you at the beginning. And said, here's some stuff I handed out yesterday.
Oh, okay.
Now, I'm going to multiply all these together. Now, since there are only 5 of them, it doesn't take long to do 5 times 4 times 3 times 2 times 1, right? So what is that? Is that 120?
Yeah.
So there's 120 ways. So somebody guessed 125, you were really close. But this would be very inconvenient if I had 15 books. Now, if I had 15 books, wouldn't I have 15 blanks up here? But then I would have 15 times 14 times 13. And again, with a calculator, that's easy, but it takes a while to do that. So there is a button on your calculator that will do this multiplication for you without you having to type in each individual number. Do you understand what I'm saying? If you don't want to type 5 times 4 times 3 times 2 times 1, we have one button that'll take care of it. All right, so I want everybody to do this. Press 5, because that's our starting number. Whatever you're starting with, that's the button. Now, press your math button. Remember, we use that one for our frac, right? But this time I want you to go across the menu till you get to prob. This chapter includes probability, so some of the stuff we're learning to do ties into probability. Everybody across the prob?
Yeah.
Now, you've got a list of stuff, you know, bunch of junk. One of them is an exclamation point. Do you see it? Go down and press that one. So now your calculator screen should look like this.
Yeah.
Press enter,
Wow.
and there it is.
So is it second math?
No, it's math,
Okay.
over to prob, down to exclamation point, and enter. Now, let's suppose that was a 15. What if we had 15 books? Then wouldn't we do 15 factorial? Oh, yeah, I haven't told you what that word. Would we do 15 exclamation point?
Mm-hmm.
All right, what is that? That's gonna be a big number.
Why does it say 1.3076?
Okay, so what does it say? 1.307,
307.
and then at the end it says E 12. Remember, that means scientific notation. So that means times 10 to the 12th. So this would be, I'm not going to keep all the decimal places. I know they're there, but I don't know what they are. But that would mean move this 12 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this number would be, let's see, that's thousands, million, 1 trillion, 307 billion. It's a pretty big number. You're going to run into a lot of those in this unit, big numbers.
Do we
Okay.
have to write it like that, or can you?
No, you can leave it in scientific notation. But that's, anytime you pop up with the E, that's scientific notation. That means times 10 to whatever comes after that. This button, this concept right here, this is called 5 factorial. So the word factorial is your exclamation point. Your exclamation point is the word for factorial. And what the factorial means is you start with that number and then multiply by every single thing. So if I said 8 factorial, that would be 8 times 7 times 6 times 5 times 4, 3, 2, 1. Right? That's what factorial means. When you are arranging things in a line, like on a shelf, if there's 5 of them, it's 5 factorial. So if I said I'm going to pick 8 of you and line you up in a line right here, how many ways can I do it? 8 factorial. When you line up things in a row or in a line, it's that many factorial. Okay? So suppose I said I'm going to take 20 kids out in the hallway and line them up. How many ways can I do that? 20 factorial. 20 times 19 times 18 and da-da-da-da-da-da-da. That's a really big number, Caroline. If you're typing that in, that's going to be a big one.
It's 2.4 and then it has decimals E18.
E18. So that's a whole bunch more zeros than I've got up here.
What's the biggest number?
There isn't.
I'm not sure there is a biggest number, but I don't know.
Could you have like 100 trillion?
Oh yeah. Oh, sweet pea. I don't want to go all political on you here, but if we don't slow down this government, that's going to be, you guys your age are going to be paying for this.
Yeah, it's gonna be a
Yeah. All right, number 2. How many ways can 9 people stand in a line? 9 factorial. What is that one? 362,000 and something, right? Everybody's typing that in? Perfect. In how many ways can prizes be awarded for first, second, and third place in a race with 10 contestants?
Would you do the 10 exclamation point and then divide it by 3?
No, but that is a great idea, and it's actually closer than you might think. Here's the deal. When we say 10 factorial, Ella, we are arranging all 10 things. Now, if I have 10 people running a race, but I'm only giving away 3 prizes, then I'm not going to use 10 factorial. I would use 10 factorial if everybody was getting a prize.
Gotcha.
All 10 people. Since, you got an idea, Daz? Oh. Since I'm only giving away 3 prizes, I'm going to go ahead and just put a slot up here. Here's first, second, and third prize. That's all I'm giving away. How many, I know one person's going to win the race, but how many choices do I have for that winner? 10. Aren't there 10 different people that could win? So someone wins. Now, how many people are possible? How many choices do I have? 9. And then 8. So instead of going all the way down, I only go the first part because I'm only doing 3
So
prizes.
for this, you wouldn't use the exclamation point, you would just do 10.
That's right. Yes, that's right. Now, later in the chapter, we're gonna learn a way to handle that, if the numbers get like uncontrollable. But for only 3, it's just as easy to do 10 times 9 times 8. Does that make sense to everybody? Okay. Mrs. Ford has 8 jumpers and 10 shirts. How many different outfits are possible? So every morning, you know, because you've seen me for a year, every morning, except virtual days, I go into my closet, I grab a jumper, and I grab a shirt. Half the time they don't match. Doesn't matter. I have a jumper and a shirt.
I like today.
Well, thank
Like
you.
spring.
Now, how many choices do I have for a jumper? 8. 8 for a jumper,
10 for sure.
Oh, jumper.
and 10 for a shirt. Now, I wear a jumper and a shirt. So what am I going to do with these numbers?
Oh, sorry.
Multiply. Remember, when we say I'm doing this and this, I multiply. First and second and third get multiplied. This gets multiplied. How many different outfits do I have? 80. Now, Mr. Ford, who dresses way better than Mrs. Ford, has 5 sport coats, 12 shirts, and 10 pair of pants. How many outfits does he have? So he's going to wear a jacket, a shirt, and a pants. So 5 times 12 times 10. 600 outfits for Mr. Ford.
Are these real numbers?
Well, the big assumption here is assuming that everything matches. You know, I mean, he cares if everything matches. So, all right, how many ways can the home row of the keyboard be arranged? The home row is like when you sit down to type. If you ever, I don't know if you guys type or not, but if you sit down to type, it's that middle row where your fingers start out. And those are the letters. How many letters are there? 9?
Letters 9.
Yeah.
Now I am going to arrange 9 letters in a row. How many ways can I do that? 9 factorial. 9 exclamation point. Because I am arranging all 9. It's like lining the people up in the hallway or something like that. All right, let's finish the page. How many ways can you answer 10 true-false questions? Now, stop. I know your gut instinct might be, oh, 10 factorial. No, stop and think about it for a minute. Here is the test. 1, 2, 3, 4, 5, 6, 7, 8. There's 10 questions on the test.
20.
So, exactly. There's 2 choices for that first, but when you sit down to answer the true false, how many choices do you have for the first question? 2, right? True or false. How many choices do you have for the second one? 2. Aren't these all 2? And since you're answering the first one and the second one and the third one, won't this just end up being 2 times 2 times 2 10 times? Or 2 to the 10th power? Remember, if you're doing this and that, you multiply. So answering 1 and answering 2 and answering 3. These blanks, that number is the choices you have to do that. All right, one more. How many ways can 4 different prizes be given out if there are 10 people in the contest? Now, you are giving away 4 prizes, guys.
So let's do it 10, 9, 8, 7.
Exactly. So it'd be 10, 9, 8, 7. Because the first prize I give out, I have 10 choices for, but if I give it to you, you're out. So now I only have 9 choices, and then 8, and then 7. Okay? You like it? Yeah, it's fun.
What math isn't fun, Kenny?
Well, good point, William. Good point.